we are gathered here for design thinking discussion on memories. So we all know what is a design thinking process. So it is a process of understanding the needs of the user. Totally we have 5 stages in design thinking: empathy, define, ideate, prototype and testing. In empathy part, we will be finding out what are all the problems that are faced by the user. So after finding out the problem, we have to define the exact problem statement. It is done in the define part. So after defining the problem statement, we have to list out the ideas. It is done in the ideate part. So after listing out the ideas, we will be defining a prototype. So it is done in the prototype part. We will be designing the prototype based on the ideas that are being listed. So after designing a prototype, we will be testing whether it meets the needs of the user. So we will be checking whether the user's feedback, based on the user's feedback, we will be checking whether the functionality is very good or not. So if it doesn't meet the needs of the user, again we will be starting from the define stage. So it is an iterative process. Okay, so here now we're going to have a discussion on the design thinking approach on memories. So let's start the discussion.
Myself Mithun Niranjan. I am here to share about the empathy part of memory devices. Today's user in this generation expect more features in the memory device, like need to store data more permanently, need to ultra fast access for CPU operations, need to low power consumption in embedded devices, need to reliable storage in safety critical application. There are more examples for the user perspective, like in smartphone there are more fast loading system, and in IoT devices low power consumption, small size, and in laptop computers there are more high speed process.
So Niranjan defined what is the empathy part. So next we have a discussion on the define part.
I am Manoj Kumar and I am here to tell you about the define part of this stage. So the user face many difficulties and technical problems that we are going to address here, and we are also going to make them into a clear problem statements. First, for the memory systems, the RAM is extremely slow as compared to the CPU speed, and the high power consumption that is required for this IoT and portable devices. And also the RAM, even though is extremely fast, is also extremely volatile. But RAM and ROM and flash are permanent, but are extremely slow. The cost of reliability and as well as performance is also extremely high. So the clear problem statements are how we can make the memories faster without consuming without consuming more power, and also cost reduction for this process.
So Manoj Kumar clearly defined what is the exact problem statement. So next we can start with the ideate part.
I'm Mukesh. I'm here to explain the ideal part of this problem statement. We can use hierarchical memory for the arrangement of data. From top levels are faster and the low levels are slower, which helps the memory to access it faster. And we can use low power SRAM for IoT devices, that helps the IoT devices to low consumption of batteries, low consumption of memories, and we can use flash memories that helps to permanently store the data, and we can also rewrite it. And VR leveling helps to extend the memories, which can be used if the same place is used again and again. The flash memory is get damaged. To reduce it, we can use VR leveling. Multi-port memories, we can use the same place for multiple times at the same. And we can use hybrid memories, that is a combination of speed and the permanent storage.
I'm Monish. In digital electronics, computers or labs, classrooms, prototype may include simulating catch mapping techniques, creating a memory map for processors, simulating memory behavior using VHDL Verilog, designing memory cells like SRAM or DRAM design. Students or engineers turn ideas into working models.
So Monish discussed about the prototype part, and final is a test one. So we're going to have a discussion on test part.
I'm Navin Balaji. Today I will discuss about the test part. Memory reaches its design goals. To test this, we include axis time, power consumption, bit per error, and cost per bit.
Okay, so we have to include the following mentioned metrics. So we have to consider the access time, we have to consider the power consumption, bit error rate, endurance, and finally the most important thing is cost. So if the design meets all the metrics, then only the design is perfect. Else again we have to start from the defined part. So it is an iterative process. So we all had a discussion about the design thinking approach on memory. So while incorporating this design thinking approach, we will be getting a more innovative solutions. So design thinking approach is one which meets, which act as a bridge between the technical knowledge and as well as the real-time problems. So when we apply the design thinking approach, whatever results we getting will be more reliable, more accurate, and it actually meets the needs of the user. So thank you all for your valuable points. Thank you.